But what I am going to do is I'm going to do like 2 or 3 examples or sums with you guys so that you can see my approach towards the sum. Because if you can get the approach right, the rest is easy. So let's quickly start by reading the question. In the diagram below, O is the center of the circle. Automatically, I go and I look at all the theorems that has to do with centers of circles. Well, I know that one is equal to that one is equal to that one. Because of radii of a circle. Automatically, I have this angle equal to that angle there. Because it is an isosceles triangle. Next up, I look at all of my theorems that has to do with centers of a circle. Theorem 1, 2, and 3. Theorem 1, I don't have a line from the center to a chord anywhere. Okay, actually I do here. But they don't tell me anything, so I'm not going to go with that. Secondly, I look at the angle at the center twice angle at circumference. Now, I don't have that because nowhere is it connected. Maybe there and there, but that kind of gives me this whole large one being twice that one. It might come in handy later on, I don't know, I don't think so. Okay? And then I've got a diameter, but it doesn't come together at a point. So I'm not going to use theorem 3 as well. So go on to the next bit of information. AB is the diameter of the circle. Not going to mean much to me now. Chord CS produced meets EB produced at D. So in other words, CS is extended to D. And EB as well to D. Then lastly it says chord EC is parallel to BS. So now I go and I automatically put in all the theorems that could apply here. Well, C2 or S2 is equal to C2 and 3 because I have an F. If you don't see it, there's my F. If you still don't see it, turn your head. It really does work. Okay? Next up, at the bottom I also have an F. So this one here is equal to that one there. Okay? I don't have alternate angles. I could have, but I don't even have that point labeled, so I'm not going to look at it. Co-interior, I'm not really going to look at it. So let's look at the next bit. Are there any tangents? No. So it says that angle CEB is X. But which theorems did I forget to look at? What about cyclic quads? Do not forget to look at cyclic quads because here I have a cyclic quad. There's one cyclic quad for me. And then as well, if I look carefully, I also have a bow tie here. Okay? So in other words, let's start with the green one. the green one here, says that the exterior angle must be equal to the interior opposite angle. So that's also x. That is also x because of parallel lines and corresponding angles. Corresponding angles. Okay? Now, let's have a look what I have further. Let's look at the black. Let's look at this black one here. Angle A must be equal to angle E because it's angle in same segment, my bow tie. So this one is x as well. But I have that A is equal to C1 and C2. Because I have an isosceles triangle. There I have 1, 2, 3, 4, and 5 angles equal to x. Oh. Say again. C1 and 2. A. Okay, sunshine, look here. Okay, angle E is equal to B3 because of corresponding angles. Angle E is equal to S2 because of exterior angle of a cyclic quad. C2 is equal to, S2 is equal to C2 and 3 because of corresponding. So here I've got 1, 2, 3. E is equal to x. There's my fourth one. But angle A is equal to C1 and 2 because of isosceles triangle. There's my fifth one. Okay? And ladies and gents, I just quickly want to remind you that I've answered the question A without actually reading question A. I answered question A without actually reading question A. Because before I even got to find 5 angles, just by applying all my theorems, I got 5 angles equal to x. Ladies and gents, if you can learn to do geometry this way, you can be successful, but it requires you know your geometry. It requires you know your theorems off by heart. Yes, sir, you had your hand up.
So S2 equals to what?
C2 and 3.
What's the reason?
Corresponding angles. There's your F. Okay. So the 5 angles that are equal to x is angle A is equal to x. Angle C1 and 2. Angles C2 and 3. Angles B3 and angle S2. Okay. Now from here, ladies and gents, we must look at the rest because the rest is actually really simple. So let's look at C1 or let's say, they first of all say, prove triangle DBS is isosceles. But those 2 angles are equal to x. Because the angles are equal, so I've got B3 equal to S2 equal to x. This was proven. Therefore, SD is equal to BD, sides opposite equal angles. Therefore, it is isosceles. So that is number 2. Number 3. Show that C1 is equal to C3. Guys, please don't see this as a completely new sum. Don't see this as being, but sir, I don't have enough info. Guys, you do have enough info. Look what you have. Angle C1 plus angle C2 is equal to angle C2 plus angle C3 because they are all equal to x. But C2 and C2 is the same angle. Therefore, C1 is equal to C3 because C2 is the same angle. Or you can simply say I subtract C2 on both sides. And what am I left with? C1 and C3 that are equal. And there's your C part answered. So now I have further that little angle there is equal to that angle there. Now the next part is, okay, I am actually lying. I didn't go through my theorems properly. The next little bit is prove that CO or BOCD prove that that is a cyclic quad. Now again, ladies and gents, we go and we ask ourselves, how on earth could we do it by what we already have? Now, remember, there's only 3 ways of proving a cyclic quad. It's either by proving a bow tie, proving that the opposite angles are 180, or that the exterior angle is equal to the interior opposite angle. That's the only 3 ways that you could do it. Now there isn't a bow tie. So I can't look at theorem 4. I can try and look at the exterior angle. Now what would be our only exterior angle is B1. But do I know anything about B1? Now, is there any of you that struggle to see an exterior angle? Please be honest with me. If you struggle to see an exterior angle, have a look at this quad as if it is a flag. And the little line is the handle of the flag. The handle has to be straight, otherwise it's not a flag anymore. The only one where the handle is straight is here. So this has to be my exterior angle. Here it's not an exterior angle because there isn't a handle going up. Okay? So, but I don't know anything about B1. So now I've got to ask myself, the only option that is then left is trying to prove the opposite angles supplementary. Ladies and gents, as you prepare for your NBTs as well, please, ladies and gents, use elimination. One lady this morning came to me and asked me questions about the NBT. And what did I do? One by one, I would eliminate all the questions that didn't fit. Because that's the way that it works for me. So in this case, I'm going to try and have a look. Isn't there something that I can maybe look at D and O? Yes. Okay, sorry. He had his hand up first. I'll come to you now. Yes, sir.
In triangle ACO, angle O, isn't it an exterior angle?
Okay, ACO. I like it. Okay, now you guys are going. Okay, let me make it maybe an easier one. Not that it's wrong, just for the other guys, because I know a lot of them with my drawing struggle to see. I forgot to look at theorem 2 properly. There. This angle here is twice that angle there. Your one would work out perfectly, because he said, look at this triangle and go exterior angle. Perfect. I would personally go and look at exterior angle. So in other words, angle COB is equal to 2 times by angle E, which is 2x, right? Why? Angle at center equal twice angle at circumference. You agree with me? But now, so this is 2x. What do I know about angle D in terms of x? Look at your triangle that they ask you to prove in B. Angle D is 180 minus 2x. Because it is interior angles of triangle DBS. I like to write that for the examiner so they know what triangle I'm working in. So therefore, what can I see about angle COB and angle D? If I add them up, what do I get? 180 degrees. Oh, therefore, angle or BOCD is a cyclic quad. Why? Because the opposite angles are supplementary. Again, it wouldn't be my first option to look at opposite angle supplementary. But because the other two options don't work out, I look at this one. Yes?
So we can use exterior angle because C1 equals to P1 same segment, but C1 is equal to C3 proven in C, therefore P1.
Yeah, that is lovely. I didn't even look at that. Fantastic. She said, guys, B1 is equal to C1 because of angles in the same segment. But I proved that C1 is equal to C3. So the exterior angle is equal to the interior opposite angle. Lovely. I didn't even think about doing that. Well done.